question 202, happy number from LeetCode. The question is asking us to design an algorithm that decide if a number n is happy or not. So what is the definition of a happy number? It says starting with any position integer, replace the number by sum of the squares of its digit and repeat the process until the number equals to 1, or loops endlessly in a cycle which does not include 1. Those numbers for which this process ends in 1 are happy numbers. So what we're going to return, the output is going to be either true or false for the number n. Let's go through an example to better understand this question. The question, this example is giving us the number 19 as the number that we are going to explore and see if it is a happy number or not. This is how we are going to decide if a number is a happy number. We are going to a square every single digit that the number has and sum up, and then we come with a new number and we do the same, and we keep repeating that until we get 1, or until it loops endlessly. So you might say, okay, if it loops endlessly, it's gonna be a broken algorithm. So how can we do that? If we go through a couple of examples, you can understand that like when we keep getting the square of the digits of a number and summing them up, we are going to get at some point repeated numbers. So this way, if we get a repeated numbers, that we know we are going through a loop, and this way we know that, and we can end the cycle. So as you see here, 2 is not a happy number, and let's go through a few examples so you can better understand the code. So for solving this problem, we'll start with this example. Let's say we have number 19. And as I mentioned, we know that if a number is not a happy number, we are going to get at some point repeated numbers. And how can we know that we are getting repeated number? One way to do that is we can use hash set. Why hash set? Because lookup in hash set is constant, and at every single step we want to check if we have that number in the set, and if we do, we know that that's not a happy number and we can just return false. Otherwise, we keep iterating until we get to 1, which we know if the number turns to 1 through the process, it's going to be a happy number. So right now we have 19 here, and we have a while loop here, which is just checking the condition to see if the number exists in the hash set or it's equal to 1. And in either case, we know what's the answer. If it is in the hash set, so it means it's not a happy number, or if it is equal to 1, we know it's a happy number. So, and then we are going to add that number in the hash set, and we are going to do the calculation for the digits that each number has here. So what I'm going to do, I'm going to use dev mod, and I'm going to get it from 10 so I can get the remaining and the new number, and make the new number using summation, and we update the number, and we go through this loop until these two conditions are not true. And if n is equal to 1, it's going to be true, otherwise it's going to be false. So as you see here, when we go through this loop, we get 100 at the beginning from 9 multiply 9 plus 1 multiply 1, and then we get 82, and then we get 19, and then we get 68, and finally we get 1 from this, which is going to be the final result that we are going to return, because n turns to 1. And in this example, when the number is 4, as you see, we get 2, and then we get 4, and then we get 37, and so on. And after 58, we get 4. And as you see, we have this 4 in the hash set already, so we know this is not a happy number. So you might say, oh, like how many loops should we go through, or like these kind of questions. So we know that, like for example, if we have a 3-digit number, like the biggest 3-digit number that we can get is 999, right? So let's go through this example. As you see, we get these numbers like when we are going through this for loop for 999, which is the biggest three digits numbers that we might get, right? But as you see here, in less than like 20 steps, we get a repeated value that we had in the hash set before, and we know the loop ends. So this is the case that when you first look at the question, you might get confused, like, and it might sound like very um, difficult and complex, but it's not. When you go through a couple of example, and when you go through the worst example that can comes to your mind, so then you know that this is the case that we can handle the situation. The time complexity and space complexity are both log n because of the while loop that we divide on 10 and the hash set that we use. We can do this in constant too, but we should use a Floyd function. Thank you.